Hello and welcome. Today, we're going to talk about something that seems so simple, just a straight line. But we're going to see how that one simple line is actually the backbone of so much of machine learning, giving computers this incredible power to predict things. Yeah, let's get into it.
So just think about this for a second. How can a machine take one number, like the hours you studied, and then predict a completely different number, like what score you're going to get on an exam? It almost feels like magic, but it's really just a beautiful, logical process.
Because at its core, that's all machine learning really is. It's not about giving a computer a bunch of rigid instructions. Nope. It's about letting it learn from experience. We just feed it a whole lot of data from the past, and it starts to figure out the patterns, the relationships, so it can make these really smart guesses about new stuff it's never seen before. Now, when we give a machine data that's already labeled to learn from, and this is called supervised learning, we're basically asking it to answer one of two big questions. And that's pretty much it. A huge chunk of machine learning really just boils down to these two simple questions. The first one is how much or how many. That's for when we need to predict a specific number. And the second one is which one. That's when we need to sort something into a category. And this breaks it down perfectly. On one side, you've got regression. That's for predicting a continuous number, like the price of a house. The whole goal there is to find the best possible line that fits the data. On the other side, you have classification. This is for predicting a category, like is this email spam or not spam? And its goal is to find a line that separates the different groups.
This visual makes that difference crystal clear, right? With regression, the line slices through the data, trying to get as close to all the points as it can. But with classification, the line is more like a fence. It's drawing a boundary between the groups. It's the same exact tool, a simple line, but used for two totally different jobs.
All right, so let's tackle that first one, regression. How does a machine actually figure out where to draw that line to answer the how much question?
Well, it all starts with an input. In the machine learning world, we call this a feature. So going back to our exam score example, our feature is hours studied. And in our little formula, we're just going to call this x1. Okay, next up, we have to figure out how important that feature is. That's the job of something called the weight, or W. The weight is really just the slope of our line. It tells us, for every extra hour you study, how much higher do we expect your score to go.
But wait, what if you studied for 0 hours? You probably wouldn't get a 0 on the exam, right? That's where the bias, or B, comes into play. Think of it as the y-intercept. It's our starting point, the baseline score if you did nothing at all.
And when you put it all together, you get this simple but incredibly powerful equation. Our predicted score, we call it y prime to show it's a prediction, is just the bias plus the weight multiplied by our feature. And that's it. That's the linear model.
Okay, so that's how we predict a number. Pretty cool. Now let's switch gears and see how we answer that other question, the which one question, with classification. The really important thing to get here is the change in thinking. We are no longer trying to predict a value that falls somewhere on a line. Now we're using that line to create a hard separation, a boundary.
And we called this line a decision boundary. Everything on one side of this line gets classified as one thing, let's say not spam, and everything on the other side gets classified as something else, spam. Simple as that.
And you see this working all around you every single day. Is this email spam or not spam? Your inbox is doing that constantly. Does this picture have a cat in it or a dog? That's classification. Is a customer going to click on this ad? That simple yes-no prediction is worth billions. These models are always running behind the scenes.
So whether we're talking about a regression line or a classification boundary, how in the world does the machine find the best possible line? This is where the learning part of machine learning really happens.
The whole process starts by figuring out what it means to be wrong. For that, we use a concept called loss. Loss is just a number. It's a score that tells us how far off our model's predictions are from the real answers. High loss means the model is terrible. Low loss means it's pretty good. The goal is to get that loss as low as we possibly can.
So how do we minimize that loss? We use a brilliant algorithm called gradient descent. It's basically the engine that drives a massive amount of modern AI. The computer starts by just drawing a totally random line, a terrible one probably. Then it calculates the loss, sees that it's huge, and it just nudges the line's parameters, the weight and bias, a tiny bit in the direction that makes the loss smaller. And then it does it again, and again, and again, thousands of times.
So early on in the training, the model looks something like this. The line is a pretty bad fit for the data points, right? You can see all those big gaps between the line and the actual data. That's the error. That's the loss that we're trying to get rid of.
But after thousands and thousands of those little adjustments, the model converges. It finds the one line that minimizes the distance to all those data points, and that gives us the lowest possible loss. At this point, the model has learned the best pattern it can from the data.
This is honestly my favorite way to think about gradient descent. Just imagine that the loss is a giant landscape with hills and valleys. Our model is like a ball we just drop onto a random hillside. What's it going to do? It's going to roll downhill, right? It naturally finds its way to the lowest point. And that lowest point in the valley, that's our goal. That's the point of minimum loss.
So we've gotten into the mechanics of it, but why does a simple line matter so much? Well, because even though it's a really basic idea, it's a fundamental building block for a ton of the technology that we all use every single day. And this quote just sums it all up perfectly. We're not telling the machine what the relationship is between studying and test scores. We're just giving it the data and the tools to discover that relationship all by itself.
It's pretty amazing what a simple straight line can do. How many things in the real world it can actually model. But it does leave us with a really fascinating question. What do we do when the patterns in our data don't follow a nice, neat, straight line? Well, that's where the journey into machine learning gets even more interesting. Thanks for joining me on this explainer.